Now I'm going to parameterize this surface. Again, I'll draw a picture. Here's the x, here's the y, here's the z. And I only care about the stuff on here, so I don't need to go behind the zy plane. And what's happening here? Well, I can get some sort of idea of the picture by, it's useful to solve for x here. 4 minus y squared minus 2z squared. So if y and z are both 0, I can plot the point x equals 4, like so. Then what happens? If z is 0, a y can be at most 2, plus or minus 2. So 2 minus 2. And if that happens, if z is equal to 0, then I can plot the points x is equal to 4 minus 2 squared, or minus 2 squared, so x is equal to 0 in that case. So if z is 0 and y is equal to plus or minus 2, that means that x is equal to 0. So that gives me some points there and there. And similarly, if y is equal to 0, then z can be between positive square root of 2 and negative square root of 2. So I can graph those. Oops. Plot those in red. So I have those points. They're easy enough to find. And notice that the biggest x can possibly be is 4. So I'm going to be connecting these to there. And it might be useful to get the level curves of things. And I'll use the level curves in terms of x. 4 minus y squared minus 2z squared. That gives me y squared plus 2z squared equals 4 minus c. Well, this is an ellipse. So if you divide both sides by 4, or 4 minus c, you'll get the standard form. But I get ellipses for all these. So roughly the shape is going to look like very elliptical. Here's one that looks like that. And I'm going to get a smaller ellipse as we come out. And I'm going to get a smaller ellipse, smaller ellipse, smaller ellipse. So I'm getting some sort of elliptical thing there. So it's similar to some curves that we've seen. And there's a very easy way to find the parameterization. And that is, I have x solved for already. So what I can do is I can just say, well, I'll let y be like the u and z be like the v, and then I can just plug in. And x is equal to 4 minus u squared minus 2v squared, where u, well, what's happening? To get all of the z and y values, the u and v values, I need to look at the biggest region that they occupy, which is here. If you look in the zy plane, it goes from square root of 2, negative square root of 2, and then it goes from 2 to negative 2. So this blue curve here looks like an ellipse there. So I can try to, and this would be, of course, if x is equal to 0, this is y squared plus 2z squared is equal to 4. So I could do something along the lines of, I could set, well, z goes between negative square root of 2 and square root of 2. And then once I have that, I can just solve for y. Y squared is equal to 4 minus 2z squared. So y is going to equal to plus or minus 4 minus 2z squared. Except my z is turned to u's. So u goes from there to positive 1. In other words, what's happening to my y's? My y's go from the left half to the right half is what it's saying. Alright, so that works. Again, I have some ugliness in the limits, so we're going to use some polar type stuff to take care of that in the next video. So stay tuned.